Hi everyone. In this video we're going to be talking about how to divide rational expressions. It's going to be very similar to our previous video, multiplying rational expressions, except that we're going to change the symbol here to division. Now we're going to still be dealing with two types of examples, the factored form examples and the standard form examples. So for standard form we're going to have to make sure we have the factored form, and for this one we're going to be able to just cancel what we have in common terms. But before we talk about this, let's review real quick on how to divide two fractions. As we did before, make sure that you pause this and treat it as a warm-up. Pause this video, try doing these two problems out, see how much you remember back from 5th grade math. If not, I'll help you out here in a second. Okay, so to divide fractions, you might remember from 5th grade or in elementary a song that said something like this. To divide by a fraction, here's a tip. Keep, change, flip. If you don't remember this song, or never learned it, or did not have a childhood, or all of the above, make sure you check in my descriptions below, and I'll post a link to this song, which will be pretty catchy. So here it is on how we solve this problem. So the song says to keep, change, and flip. So we're going to keep the same fraction. The first one, we're going to keep it as 2/3. We're going to change the sign to the inverse operation, which is multiplication. And then we're going to flip the last fraction as 3/4. This is where the song comes from, or the term for keep, change, flip comes from. We're going to keep this term. We're going to keep this term, we're going to change it, and we're going to flip it. Okay, now from the previous examples that we did in the last video, now that we have our two fractions that we're multiplying, we can start canceling some stuff out, and we can see that these three are going to simplify, and the 2 and the 4 will also have common terms, and we can simplify that to 1 and a 2. When you multiply your fractions across, you're going to be left with just 1/2. Now, on this other example, this 8/12 divided by 1/3, we'll do the same thing. Keep, change, flip. So we're going to keep the first fraction the way that it is, 8/12. We're going to change the division to the inverse operation to multiplication, and then we're going to flip the last fraction as 3/1. Now, here, you can multiply them across, and then you can find the common terms, or you can write it in factored form. I prefer it in factored form because I can see what cancels out automatically. So I'm going to change this 8 to 2 times 4. And I'm going to change this 12 to 3 times 4. By doing that, I can see that we have common terms in the numerator with the 4's and with the 3's. And we're left with just 2 in the top and 1 in the denominator. So the answer comes down to 2. Alright, so if you need help reviewing dividing fractions, go to the description below on this video, click on the link, and you can listen to a song that shows several examples and helps you remember these rules of dividing by fractions. We're going to take these exact same rules and we're going to apply it over to divide rational expressions. So let's start with this first one. Why don't you go ahead and try it? Keep, change, flip. Pause the video. Try this example on your own and see if we get the same solution. Alright, so let's solve this together. I'm going to first start by writing out the problem by keep changing and flipping the symbols. So I'm going to start with the first one. I'm going to keep the first fraction as 24 x minus 5 x plus 7 divided by 7 times x minus 1. We're going to change the sign, multiplication, and then we're going to flip the last fraction. So we're going to write the x plus 7 and the x minus 1 as the numerator. So notice how we keep this one, stays the same. We change the symbol, and then we flip the last fraction. Keep, change, flip. Now that we have done that, we can combine everything into one fraction all together, or we can start simplifying and canceling some common terms from the numerators and the denominators. Notice how here I have a common term with the x minus 5 in the numerator and the denominator, and I also have an x minus 1 in the numerator and the denominator. I can continue to simplify the numbers. These numbers can also simplify the 24 and the 7 and the 14. So which ones are these have common terms? The 24 and the 14 are both divisible by 2. So I'm going to do that. I'm going to divide it by 2, and I'm going to change this to 24 divided by 2 is 12, and 14 divided by 2 is 7. When I multiply across, I'm going to combine my two fractions together and have my final solution. And it comes down to this. I have 12 on top, x plus 7 times x plus 7. In the bottom I have 7 times 7, which is 49. And no parentheses in the bottom. So this comes down to my answer. And I can rewrite this so that the 49 is right below. Now, this is actually going to be my solution. There's nothing to simplify anymore. The 12 and the 49 have nothing in common, and then there's nothing that I can divide numerator and denominator to cancel each other out anymore. We are done. This is it. Now, some of you might be wondering, why is it that we don't cancel the x plus 7 and the x plus 7, or this 7 and this 7? Okay, if you're wondering that, then I'll show you a quick example on why that does not work. And I'll show you to you here on the side. So if we were to multiply these two fractions, the 1/2 times 1/2. How do we multiply two fractions? We multiply them across. We need to multiply this across and these two as well. So when we do that, we get 1 in the numerator and 4 in the denominator. Notice how these numbers do not cancel each other out. They only cancel each other out when you're dividing by each other, right? So if they're dividing and they have the same term, that's when you can cancel them out. When they're side by side, we're simply just multiplying the two fractions. Hopefully that helps if it created any confusion. But remember, this is going to be our final answer. All right, let's try one more example and we'll call it a day. Again, for this example, notice how this example is not going to be in factored form. So we need to find the factors of these first before we keep, change, flip. Why don't we pause this video and give it a try. All right, let's solve these problems together. This last one. So I'm going to find the factors of all of these four polynomials, and I'm going to start by doing that in my head. If you want an example of how to simplify these, or if you want a tutorial or a video on how to do these by hand versus on your head, just send me make a comment below on this video, and I'll make another video to remind you on how we did these 4 different examples. But hopefully by now we know how to factor, we know how to do our 3 columns, how to find the factors of the first column, the factors of the third column, cross multiply, and add up to the b term in the middle. If we need a review on that, comment below and let me know what you need, and I'll make another video just for that. All right, so let's solve this problem. Let's change it up so that I change this problem to a multiplication and I flip it. So keep, change, flip. All right, so for the first term in the numerator, the factor is going to come, the problem is going to look like this. I have x squared plus 7x plus 10 stays the same. X squared minus 9x plus 14. I'm going to change the symbol to multiplication, and then I'm going to flip the second fraction as x squared minus 6x minus 7. And in the denominator, I now have x squared plus 6x plus 5. Now that I have it as a multiplication problem, I can find the factors for each one of those polynomials, and then I can start canceling the terms that they have in common. So I'm going to do that next. Here as a numerator for this x squared plus 7x plus 10, I notice that 2 times 5 gives me 10, and 2 plus 5 also adds up to 7. So my factors are x plus 2, x plus 5. In the denominator, I have x squared, 9x, and 14. To get a 14, I have to multiply 2 times 7. And notice how 2 times 7 also adds up to 9, but it's negative. So I need to make them both negative to give me a 14. So my factors are x minus 2, x minus 7. On the other fraction, I find the factors of 7. 1 times 7 gives me 7, and when you add them, they can also subtract to give you a negative 6. But to get a negative 6, I need to make that one a negative as well. So I'm going to be left with, in the numerator, I have x minus 7. Sorry about that. X minus 7 times x plus 1. In the denominator, I'm going to do the same thing. I'm going to find the factors of these three terms, x times x, 1 times 5, and that adds up to 6. So these are my two factors, x plus 1 and x plus 5. Now that I have everything in factored form, I can continue to go and figure out what is it that I have in common. Notice how I have an x plus 5 here, an x plus 5 here, an x plus 1, an x plus 1. The x minus 7s are also the same, so I can start canceling all these common terms that they have. Let's start with the x plus 5, then the x minus 7, and finally the x plus 1s. Everything comes down to simplifying to just the x plus 2 and the x minus 2, and I can find my solution and write it as x plus 2 divided by x minus 2. And we're done. Again, don't forget to check below in the description to listen to the song How to Divide by Fractions if you need a review, or if you just want to jam out to what could possibly be your next favorite song during this quarantine. Have a great day, guys, and I'll talk to you later.